Bismillah ar-Rahman ar-Rahim. Assalamu alaikum wa rahmatullahi wa barakatuh. I am Ayman Ibrahim, a member of the SRI group. Now I'm going to discuss the second part of this topic, starting with the odds. I do recommend that you see the first part of this topic, that is discussing the risks, because this would make more sense for you if you did watch the previous one. So I think a good way to understand the odds is to compare it to the risk. As you remember, the risk is, or the risk compares the number of diseased people to the number of the population. The odds, however, is a little different. It compares the number of diseased people to the number of healthy people. What's the difference, you may ask? Here, the population includes everyone, while here, healthy people only include healthy people. So, if we look at the equation, the odds equals the number of cases or diseased divided by the number of non-cases or non-diseased or healthy. A visual representation will make this very, very clear. Imagine this circle is the whole population, and of this population, 1/3 is diseased while the others are healthy. If you want to calculate perhaps the risk in the population like this, we would divide the number of cases by the whole population. So this is the risk. But if we want to calculate the odd, we will also use the cases, but we'll divide them by the non-cases. You see? So there is a subtle difference between these two. You remember when we calculated the risk, we used to compare the risks in two groups in a measure called relative risk. The odds has a very similar concept, but it's called the odds ratio. It's basically the same. You remember when we used to divide the risk in the exposed by the risk in unexposed to calculate relative risk. Now we just divide the odds in the exposed by the odds in the unexposed to calculate the odds ratio. And the same things can apply, as if the odds ratio equals 1, that means exposure does not make any difference. If the odds ratio more than 1, that means exposure is risky or dangerous. If odds ratio is less than 1, that means exposure is protective and safe. Now it's time for an exercise. You remember we've used a similar table in the calculation of risk. Now we're calculating the odds. So what if we want to calculate the odds of having the disease in the exposed population? We would, as the equation says, we will divide the number of cases by the number of non-cases. In the risk, we used to divide them by the number of the total population, but we're not going to do that now. We're going to divide the cases by the non-cases, like this. So 90 divided by 10, which very clearly will be 9. So the odds in the exposed, the odds of having the disease in the exposed is 9. If you want to measure that in the non-exposed population, we do the same. We just divide the 300 by 600, divide the number of cases by the number of non-cases, and that will come up here as 0.5. Okay, what if we want to calculate the odds ratio? The odds ratio is the odds in the exposed divided by the odds in the unexposed, am I right? So we would divide 9 by 0.5, and that would be 18. So the odds ratio here is 18. The number of cases, or the odds in the unexposed divided by the odds in the unexposed. It's really pretty simple. Just a quick tip that actually is very useful. I never knew about this before, that you can, although risk and odds are different things, you can use the risk to calculate the odds without a table. And it's a pretty simple equation. The odds equals the risk divided by 1 minus the risk. So whenever you have a risk but you want to know what's the odds, you can simply do this simple calculation and you'll get it. Okay, now it's going to get interesting. Now we're going to compare the risks and the odds. What is the difference actually in practice between these two? Well, we remember that both the risk and odds measure the chance of disease incidence. Both of us give us information about how much our people are developing the illness, just in different ways. The risk does that in comparison to the population, while odds does that in comparison to the healthy people, or the non-cases. And similarly, the relative risk and odds ratio both measure the comparative chance. That means we can use any of these to compare the chance or incidence into different groups. But the difference here lies that the risk is better and more easily understood than the odds. It makes more sense to us when we use the risk. So it's actually more preferred. So why do we bother with the odds then, if the risk is preferred? Well, sometimes it's the only thing we can calculate. Some studies, like the case control studies, does not really allow us to calculate the risk, because in order to calculate the risk, we need a number of diseased and healthy people that represents the population. And in case control studies, our group of healthy people and group of sick people is artificial. It does not really represent their distribution in the population, and therefore we cannot calculate the risk, but we can calculate the odds. Sometimes it's more convenient, such as if we think about logistic regression, it's actually more convenient to calculate the odds than the risk. And sometimes odds is actually not so bad. Sometimes odds is a good approximation of the risk. And that's also that works under a certain condition, that is, the disease being studied is actually rare. And I'm gonna show you why. You remember imagine this is a population. Okay, we're gonna do a similar calculation that the one we've done to compare the risk and the odds. So this is the population, and there is very few people who are sick. The sick people are not very prominent in this population. So if you want to calculate the risk, we will divide the number of cases by the population. But if we want to calculate the odds, we will divide the number of cases by the number of non-cases, right? So notice that when the disease is rare, the denominator of these two is very similar. It's not very different. Although it's a little different, but not very different. If the diseased people were having more chunk of the population, then we would have to suffer from a completely different denominator in these two examples, you see? But because the disease is rare, the outcome of these two calculations would be similar. Thank you very much. I think we're done with now risks and odds altogether. So I hope really this was useful in a way and made things a little simpler. Thank you for watching.